Hi, my name is Arasu, and in this video I'll be explaining how to derive the SUVAT or constant acceleration equations using calculus. Now, fair warning, this video does require a prior knowledge of what calculus is. I do have another video where I explain how to derive the constant acceleration equations without using calculus and using geometry and graphs and stuff. So if you don't know calculus, make sure to check that out. So let's get into it. The first SUVAT equation I'll be proving is v is equal to u plus at. And we first start with acceleration. We know that acceleration is the rate of change of velocity with respect to time. And rewriting, we get velocity is equal to the integral of acceleration with respect to time. If we evaluate this, we get v is equal to at plus c. Now, since this was an indefinite integral, we have a plus c here, and we can usually find that by letting t, in this case, equal to 0. And when t is equal to 0, what this means is that c is equal to my velocity at the initial time, or my initial velocity, which is represented as u. So, c is equal to u. And if we substitute this back in, we get v is equal to u plus at. The second SUVAT equation that I'll be proving is s is equal to ut plus half at squared. Now, to get to this, we start from velocity. Velocity is a derivative of displacement with respect to time. And displacement is the integral of velocity with respect to time. But we already have another way to represent velocity. v is equal to u plus at. And we can substitute that in here. And we get s is equal to the integral of u plus at with respect to time. And if we evaluate that, we get s is equal to ut plus half at squared plus c. Now, again, if we let t equal 0, we get s is equal to c. Or in other words, c is equal to my displacement when time is 0. But since I haven't moved when we start measuring time, my initial displacement is 0. So c is also 0. And we get s is equal to ut plus half at squared. These were the only two that need calculus to derive, and the rest can be derived using a combination of these two. The third SUVAT equation, s is equal to vt minus half at squared, is first given by rearranging the first SUVAT equation. So what we do is we solve for u and we substitute that u into here. We get s is equal to v minus at, the whole thing, times t, plus half at squared. And if I expand it and evaluate it, we first get vt minus at squared plus half at squared, and that simplifies to vt minus half at squared. The fourth SUVAT equation is v squared is equal to u squared plus 2as. And what we need to do to get this is eliminate time from the first two equations. So I'll start with v is equal to u plus at, and I will solve for t. And I'll substitute this value, t is equal to v minus u over a, into the second equation. So I get this. Now if I expand it, now I'll multiply both sides by 2a. Here I have 2as is equal to 2u times v minus u plus v minus u the whole squared. Now I'll expand everything out. I get 2as is equal to 2uv minus 2u squared plus v squared minus 2uv plus u squared. Now if I simplify this, I get, so I first get 2as is equal to v squared minus u squared, and rearranging, I get v squared is equal to u squared plus 2as. The fifth SUVAT equation is s is equal to a half times u plus v times t. To arrive at this equation, I need to eliminate the acceleration variable. So, like the previous two equations, I'll start with the first SUVAT equation and solve for a. I get a is equal to v minus u over t, and if I substitute that into the second equation, I get s is equal to ut plus half times v minus u over t times t squared. And simplifying, I get ut plus half v minus half u times t. And if I factor out the t and evaluate this in here, I get a half u plus a half v the whole times t. And factor out the half, you get s is equal to a half times u plus v times t. So that was all 5 constant acceleration or SUVAT equations explained using calculus and algebra. This explanation is more straightforward than my geometric and graphical one, but that's because you need to understand how calculus works to understand how I got these, the first two. That's it for this video. Thanks for watching, and I'll catch you in the next one.